A factory's layout is like the blueprint for its operations. It dictates how materials move, where machines are placed, and how workers interact with their environment. A well-designed layout can be the difference between a factory that runs smoothly and one that is constantly plagued by bottlenecks and inefficiencies. When we optimize the layout, we optimize the entire system. Think of it like a kitchen. A well-organized kitchen allows a chef to move effortlessly between the stove, the sink, and the countertop. They can chop vegetables, stir a pot on the stove, and wash dishes without missing a beat. But in a poorly designed kitchen, the chef would be constantly bumping into things, walking back and forth unnecessarily, and wasting valuable time. The same principle applies to manufacturing. A well-designed layout minimizes unnecessary movement, reduces material handling costs, and ensures that each step in the production process flows smoothly into the next. This results in faster production times, lower costs, and higher quality products. In essence, the layout is the foundation upon which efficiency is built. In today's competitive manufacturing landscape, optimizing the layout is no longer a luxury, it's a necessity. Companies that fail to do so risk falling behind their competitors who have embraced the power of efficient layout design. One common type of layout is the process layout, also known as a functional layout. This layout groups similar machines or operations together. For example, all the lathes might be in one area, the milling machines in another, and the grinding machines in yet another. This type of layout offers several advantages. First, it allows for specialization of labor and equipment. Workers can become highly skilled in operating specific types of machines, leading to increased efficiency and productivity. Similarly, specialized equipment can be purchased for each process, which can be more cost-effective than purchasing general-purpose equipment. Second, a process layout offers flexibility. Because machines are grouped by function, it's relatively easy to adapt to changes in product design or production volume. New machines can be added, or existing machines can be reconfigured without disrupting the entire production line. Third, a process layout can reduce bottlenecks. Bottlenecks occur when one stage of the production process is slower than the others, causing delays and disrupting the flow of work. In a process layout, bottlenecks can be addressed by adding more machines or workers to the bottleneck operation. Overall, the process layout offers a number of benefits for manufacturers, particularly those that produce a variety of products or have fluctuating demand. While the process layout offers several advantages, it also has its limitations. One of the main disadvantages is the increased material handling costs. Because similar machines are grouped together, materials often have to be transported long distances between operations. This can be time-consuming and expensive, especially if the facility is large. Another disadvantage is that the workflow in a process layout can be less efficient than in other types of layouts, such as a product layout. In a product layout, machines are arranged in a linear sequence that follows the order of operations required to produce a specific product. This linear flow minimizes material handling and reduces the overall production time. Additionally, process layouts can lead to increased inventory levels. Because materials are often moved in batches between operations, there is a greater need for work in process, WIP, inventory. This can tie up valuable capital and increase the risk of obsolescence or damage. Finally, scheduling can be more complex in a process layout. Because multiple products may be competing for the same resources, careful planning is required to ensure that all orders are completed on time. This can be a challenge, especially in high-mix, low-volume production environments. Section 4. Factors to consider in process layout design. When designing a process layout, several factors must be considered to ensure efficiency and effectiveness. One crucial factor is material flow. The layout should be designed to minimize the distance materials travel between operations. This can be achieved by placing departments that share a high volume of material transfer in close proximity to each other. Another important consideration is safety. The layout should provide adequate space for workers to move around safely and operate equipment without risk of injury. Clear pathways, designated work areas and proper signage are essential for creating a safe working environment. Flexibility is another crucial factor. The layout should be adaptable to changes in product design, production volume and process technology. This can be achieved by using modular equipment, flexible work cells and adjustable partitions. Scalability is also important, especially for growing businesses. The layout should allow for easy expansion or reconfiguration as the company's needs change. This might involve leaving space for additional equipment, designing flexible workspaces, and utilizing modular systems that can be easily expanded or rearranged. Section 5. Examples of process layout in various industries. Process layouts are commonly used in a wide range of industries. In manufacturing, a machine shop is a classic example of a process layout. Lathes, milling machines, drill presses and other equipment are grouped by function, and workpieces are routed between these departments based on the operations they require. Hospitals also utilize process layouts. Different departments like radiology, surgery and emergency care are strategically placed based on the services they provide. Patients are moved between these departments based on their individual needs. Even service industries like restaurants employ process layouts. Consider the kitchen in a typical restaurant. Different stations like food preparation, cooking and dishwashing are strategically located to optimize workflow and minimize movement. These examples demonstrate the versatility of process layouts and highlight their adaptability across different industries. The key takeaway is that the specific implementation of a process layout will vary depending on the unique requirements of each industry and organization.